As students, nice to meet you today. In this class, we talk about um, an assignment problem. Okay, and this assignment problem is a very important because a lot of steps are used here. Let me take that particular problem now. The problem is this: there are three jobs J1, J2, J3, and there are four machines are there: M1, M2, M3, M4, and we have to assign these three jobs to these four machines so that the assignment cost should be minimum, and that's the way we have to do. Okay, so we usually do that. This is an unbalanced problem, therefore we have to make it a balanced problem by adding one more job with the with the zero assignment costs. With the zero assignment costs, we can make this a unbalanced problem a balanced problem. The one more difficulties is there. This is a restricted problem. We have to make this restricted problem an unrestricted problem uh, by removing these unassigned values by infinity. Okay, that's what is step number 2. We can change the restricted problem an unrestricted problem by changing the blank space into infinity costs. Okay, we are assigning the infinity cost for unassigned cells here. This is step number 2. Now coming to step number 3, so now it is a balanced one and unrestricted one, so we can follow the Hungarian method. And the Hungarian method, the first step is row-wise reduction. Means what? We are finding out the least element in each row, and subtracting in the corresponding uh, uh, elements, subtracting from the corresponding elements in the same row. So you take the first row, the least element is 2. So subtract that 2 from all other entries in that particular row. So 2 minus 2, you will get 0. 5 minus 2, you will get 3. Uh, 3 minus 2, you will get 1. And 5 minus 2, you will get 3. This operation we have to do with all other rows. Okay, so you take the second row, the least element is 1, subtract this one from all other entries in that particular row, we will get this particular row. 4, this least element is 1, 4 minus 1, 3, 1 minus 1 is 0, infinity minus 1 infinity, 2 minus 1 1. The same way we have to do for this row and this row also. In this row the least number is 3, so subtract 3 from all of the entries. You will get here infinity minus 3 infinity, 3 minus 3 0, infinity minus 3 you'll get infinity, and 7 minus 3 will get 4. So in the last row you take 0 as a minimum, and you will get the same row as we see here. Now the next step is that the same row wise reduction we have to do by column wise reduction also. Row wise reduction we have done here, we have to do by column wise reduction. So least element here is 0, the same least element is here 0, therefore 0 minus 0 0, 3 minus 0 3, infinity minus 0 infinity, 0 minus 0 0. Similarly here least element is 0, 3 minus 0 3, 0 minus 0 0 minus 0 0 minus 0 0. So here also the least element is 0, 1 minus 0 1, you are getting here infinity minus 0 infinity infinity 0. The last one least element is 0, the same column you will get. This is called column wise reduction. Then afterwards we have to draw the lines through maximum number of zeros. Okay, starting from the maximum number of zeros we have to draw the lines. Okay, now the first row you have only 1 0, in the second row you have only 1 0, the third row you have only 1 0, but in the fourth row you have 4 zeros. Okay, 4 zeros you have in the last row. Therefore we have to strike out, that is the row number on, or line number 1, we say line 1. Okay, now afterwards 4 0 rows our columns over. Now we have to search for 30 rows or columns. So here no, only one zeros. Here only one zero. Here only one zero. This is striked out already. This direction one zero. This direction two zeros only. This direction no zero. Here no zero. Next we have to come to the two zero occurring rows or columns. So two zero occurring, no zero, no, only one zero, only one zero. And here I have the second zero, second line I have here. Am I correct? And next we have to search for a single zero occurring rows or columns, and we see that the first row have the single zero. I can strike out the third lines I have here. So now how many lines we have? We can draw three lines here. Am I correct? These three lines must be equal to the order of the matrix here after the altered of the given matrix 4 by 4 matrix we have. So this number of lines drawn must be equal to the order of the matrix, but here the order of the matrix is 4, but number of lines we can draw is only 3, so optimum is not reached. To get optimum, what we have to do, look at this. Here out of line elements we have to take. Here this is one out of line element, this is one out of line element, this is another left out of line element, out of line element, out of line element, out of right element. So 1 2 3 4 5 6 out of line elements are there. Among them, which is very minimum, we have to identify 3, infinity, 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 4. So 1 is the minimum. Am I correct? This minimum number you subtract from this, from this, from this, from this, from this. I mean this number you subtract from all other out of line elements. Okay, then you write here. So what you will get? 0 you will get here, infinity you will get here, and 3 minus 1 2 you will get here, infinity minus 1 infinity you will get, and here infinity minus infinity. Okay, so at the intersecting point you add this least number. Here is one intersecting point, add this number 1. Here another intersecting point, add this number 1. Okay, that we have to do. So 1 1 we have. All other elements on the lines you write as it is. All other elements on the line you write as it is. Zeros here, 0 1 3 0 0 0 0 and 0. Okay, right. Now after altering these adjustments, now we have to draw the lines. Okay, so now if we draw the lines through maximum number of zeros, we have to start with the maximum number of zeros. Okay, so here possible maximum number of zeros are 4. So let us take the first row. No, only one zero. Second row, two zeros. Third row, only one zero. Last row, three zeros only. Here only two zero. Here in this table you see, in these two zeros, in this one zero, here one zero. The next possible maximum number of zeros are three zeros. Here only one zero, here two zero, here one zero, here three zeros available. Strike out that is number 1, line number 1. Okay, right. Come this side, no 30, no 30, no 30, no 30. Now come to the next number of zeros maximum. Maximum number of zeros next possible is two zeros. So I can strike out this as a second line because two zeros are there. I cannot strike out this because only one zeros is there. Therefore this not possible. This direction not possible for two zeros. Here already strike out. Therefore this zero you should not take. Yes, the next one single zero occurring rows or column. The first one we can strike out, and then the third one we can strike out, and total number of line comes 4. Okay, right. Now the optimum is reached. Okay, if the number of lines equals the order of the matrix, this is 4 by 4, number of lines 4, then optimum is reached. So here since the number of lines drawn equals the order of the matrix, then the optimum is reached. The next step that we have to do optimum assignment. Okay, now what they do there, from this particular matrix only 0 assigned places you take. This one, this one, this one, this one, this one, this one, this one. So all these 0 assigned places cells only you take into account here. 0 assigned cells only we have to take into. Okay, so you look here, 0 comes here, 0, 0, 0, 0, 0, 0 here, here, right? Now other cells don't write, other cells, that is non-zero elements, you don't write here. Okay, right, we have to assign now such that each column have only one assignment, and each column should have only one assignment, and each row should have only one assignment, because there is a condition that each job can be assigned to only one machine. Okay, that's very, very important. A single job cannot be assigned to 2 or more jobs, only one machine we can assign. The same way, a single machine can be assigned to a single job only. So here, if you assign that way, I am assigning this one. So this machine I cannot assign to any other job here. Therefore, I'm striking out. Okay, then I am coming to the second assignment. Okay, the second assignment I am assigning this. I am striking out this, because if you assign this particular machine to this particular person, we cannot assign this particular job to this particular machine. So strike out. Come to the third one. I can assign this one because this is striked out. I can assign this one. So a single job is given to single machine. The last possible is that this one. Since already we have assigned this, we are striking out. So only thing that we can assign is this one. So this, now you see there, only each row have only one assignment, each column have only one assignment. Am I correct? And this is called the optimum assignment. Optimum assignment, we say. So this definitely will give us the optimum assignment of the job to the machines. Okay, optimum assignment for the job to the machines. So fourth job is a dummy job we have given with the zero assignment cost, therefore that will not affect us. So first job should be given to the first machine, second job should be given to the last machine, and third job should be given to the second machine, and the dummy job should be given to the third machine. So here the third machine will not take any job. That is what we have to understand. Okay, so J1 will be assigned to M1 machine, J2 will be assigned to M4 machine, and J3 will be assigned to M2 machine, and last dummy job will go to the third machine. Okay, this is an optimum assignment. Why? Because this gives us a minimum assignment cost. Now look at that. If J1 is assigned to M1, we will get 2 rupees. If J2 is assigned to last machine, 2 rupees only needed, and if J3 is assigned to M2, 3 rupees. So 2 plus 2 4, 4 plus 3 7 plus 0. So rupees 7 is the only the optimum assignment cost. So we cannot find the assignment cost less than this. Okay, and this particular method we call it as the Hungarian method, and this way we can solve a problem which is unbalanced one and a restricted one. So with that, I am coming to the end of this session. Thank you very much.